comma, total derivative maxima and minima, comma, evaluation of definite and improper integrals. So these are the contents in calculus chapter. It is both differential and integral calculus, which we have studied in 11th and 12th standard. So epsilon delta method limit definition, it is 5 marks, 8 marks question. Due to 1 mark, 2 marks bits entrance purpose, we will evaluate that limits problems by formula based method or some other simplification method. Okay, L'Hospital rule, all these things come. Limit. Let fx be a function defined in an interval. We don't know that interval, say capital I. It is not integers, and a belongs to I, that is real number a is. Then a real number L is, I am not giving epsilon delta method, or if you open that calculus basic definition, that will that problems got the whose answers got by the limit values got by epsilon delta method only, which is descriptive method, 8 marks 5 marks question. Okay, L is said to be limit of fx at x is equal to a if, just for problems purpose I am giving this one, limit LT x approaches to a fx is equal to L, or this is also denoted by LIM x approaches to a fx is equal to L. Now see, fx is the given function, x is any number in the domain of the function. What is that domain of the function? Interval I. So x approaches to a, this is pronounced or read as x tends to a or approaches to a. That means x is very closer to a, nearly to a. That means either left side closer to a or right side closer to a, but not exactly a value. Here tends to a means x value not equal to a. X approaches to a, approximately to a, approximately to a. Let me think this is a value. So approaches to a in real numbers means either left hand side or right hand side. Okay. So whenever x is very closely to a, then fx is also closely to L. Okay. So for example, what is this? Limit x square x tends to 2. What it gives? 4 only. That means what we have done here, putting x is equal to, that is not the procedure. It is came by epsilon delta method, which is descriptive method. Okay. It is available, one problem available in your material or any calculus book. Okay. But due to entrance purpose, just what we are doing using formulas based method or some simplification. Here, what is the meaning of this limit? X is nearly that is closely to 2, approximately equal to 2. Then x square is always approximately equal to 4. X square value is not 4. X square is approximately tending to 4. That is, x square is almost equal to 4. 3.999 or 4.0001. That means either that side, right side, it is greater than 4. Left side, less than 4. X tends to 2 means there are two sides. Left side to 2 means less than 2. Right side to 2 means greater than 2. So less than 2 means don't say 0, 1, 2 that numbers. Almost equal to 2, less than 2 means 1.999 approximately. Greater than 2 almost equal to 2 means 2.01, 2.001 like that. Okay, this will belongs in 10th standard, 11th standard, 12th standard. They have given first 2 pages how the limit came. Okay, all these things. So for example, see, on the real number this is minus infinity plus infinity. If I take 2 here, so this direction is called left hand side to 2. This direction is called right hand side to 2. So the left hand side direction is denoted by x tends to 2 minus. The right hand side, that x going to 2 is denoted by x tends to 2 plus. That I will give next. Left hand limit, right hand limit. So while calculating both left and right limits, in some problems both are equal, in some other problems both are unequal, like that. So not necessarily compulsory both left and right limits are equal. Okay, like that. Next, the left hand limit, that is LHL, abbreviated as LHL, of fx at x is equal to a is limit x approaches to a minus fx, that is limit x approaches to a from which side? Less than a, fx, and the right hand limit of fx at x is equal to a is the abbreviated as RHL, limit x approaches to a plus fx, that is limit x approaches to a x greater than a fx is denoted by, similarly is denoted by So in some problems we have to find both LHL and RHL, left hand limits, right hand limits. Okay, in some other problems we need to find directly this limit extends to a. Okay, so I will give you examples, then you will, after practicing, you will get an idea where you apply both left and right limits, where you apply direct limit. Okay, so in some problems both left and right limits equal or unequal. Okay, like that. If limit fx x tends to a minus not equal to limit x tends to a plus left limit not equal to right limit, then limit x tends to a fx does not exist. Next, limit x tends to a minus fx is equal to limit, so sometimes I am writing LT and some other times I am writing LIM, fx both are equal to some number L if and only if, this is the symbol stands for equivalence, or if and only if limit x tends to a fx is equal to L. So this is meaning of if and only if both sides exist. Whenever the original limit value equal to L, its left and right limits are also equal to that L. Whenever left and right limits are equal to that L, this original limit value is also L, one-sided limits. Okay. Good evening to all. Today we are going to discuss problems on limits with some more definitions or note points, and continuity, differentiability, one example, and depending on the situation, either integration or partial derivatives, maximum, minimum, that topic. Okay, so in the last class I have given the definition of limit followed by left and right hand limit. Okay, so whenever these two are unequal, then original limit value exists. Whenever these two are unequal, then your limit value does not exist. Okay, so sometimes we have to find left and right limits, and some other times we have to find direct procedure, that means direct limit value, direct limit problems. Okay, so in some problems both left and right limits may be equal, in some other problems may not be equal. Okay, now definition, this is everyone knows, absolute value of x and greatest integer function, that is step function, that is square bracket function. 1. Absolute value of a real number x is denoted by mod x. Read as mod x, that is absolute value of x, and is defined as mod x is equal to x if x greater than 0, minus x if x less than 0, 0 if x is equal to 0. That is three cases: less than 0, greater than 0, 0. Covers all real numbers. Okay, plus x, minus x and 0. The graph of this function is, it is in the form of V shape. This is y axis, x axis, origin. So this is fx is equal to x graph, and this is fx is equal to minus x, or simply y is equal to minus x. Y is equal to minus x, and this is y is equal to plus x. Graph of mod x, this one. Okay. 2. This is step function or bracket function, that is greatest integer part function. This is equal to the greatest integer which is less than or equal to x, that is x is a given real number. Now we have to find this bracket x, means find all integers less than or equal to the given x. Of all these, the greatest is called, that's bracket x function, that is greatest integer part function, that is also called step function. Okay, for example, square bracket 2, that means x value 2, on the number line collect all the numbers, integers less than or equal to 2 and find greatest, that is 2 itself. Square bracket 2 is 2 itself. 2.5. Now x is 2.5, collect all the integers less than or equal to 2.5 and then find greatest of all these integers, that means 2 only. Square bracket minus 3.1. Now I have taken x is equal to minus 3.1. Go to your number line, collect all the integers less than or equal to minus 3.1 and then find greatest. So this becomes minus 4. Okay, and the graph of this function is, everyone knows. Just I am considering first part, that is positive part. 1, 2, 3. Similarly here also randomly 1, 2, 3. 0 to 1, that square bracket x value is 0. 1 to 2, take any real number between 1 to 2, the square bracket x value is 2. Sorry, 1. Take any number between 2 to 3, the square bracket x value is 2. So what indicates? So it is look like in the steps. That's why it is called step function. Okay. So this is graph of and this is discontinuous at integers and continuous at all integers. Mod x is continuous at every number. Okay, graph of square bracket x, and this is graph of mod x. Generally, if you find limit x tends to 1 square bracket x or limit mod x extends to, in such cases you find left and right limits. Okay. Now I am showing one example how to find left and right limits, and then the limit exists or not we will check. Example, evaluate limit x tends to 0 mod x by x. Solution. So I told you already in the last week, x tends to, right hand limit denoted by x tends to a plus, left hand limit denoted by x tends to a minus. The power position, that is the number, that is superposition, that is called power position. If it is plus symbol, then it tends to a from right side, that indicates greater than a. The power minus indicates left limit, that means tends to a from which side? Less than a, that is left to a. Okay. LHL. LHL means left hand limit at x equal to 0. Here a is nothing but 0. So what is the notation? Limit x tends to 0, x less than 0. In the last class I have given the notation, left hand limit at a, right hand limit at a. Here a is 0. Function fx is mod x by x. So when x less than 0, what is mod x? Just now I gave the definition. That means minus x. Minus x by x. So x cancelled, and this gives limit x tends to 0 minus 1. Limit of a constant is itself, does not change. Okay. Since limit x tends to any number k is equal to k. What is this k? Constant. Limit of a constant is itself. Derivative of a constant is 0. Okay. Integration of a constant is constant into the variable. Okay. These are the three different operators. The next one, right hand limit at the same number 0. Right hand limit, that is RHL, at x is equal to 0. Limit denoted by x going to 0 and greater than 0. Function is mod x by x. When x greater than 0, I gave that mod x is equal to plus x. This simplifies to limit x tends to 0, x divided by x. That means both are cancelled. That means you will be getting limit x tends to 0, 1. Constant limit is itself. So we have different answers, that is left and right limit are unequal. Therefore LHL, left hand limit not equal to right hand limit at x equal to 0. So what can you say about from this? Therefore limit x tends to 0, the given function does not exist. Similarly, limit x tends to a square bracket x is equal to does not exist, where a is any integer. Just take 0 as above, later you do whether exist or does not exist. Now I am giving some standard limits. Using this, we can able to find the limit of the given function, standard limits. Okay. So limits can be evaluated using standard limits and some simplification, rationalizing factor, taking common number, using algebraic formulas, trigonometric formulas. That means the given function is going to become simpler, and then evaluating the limits, many cases like that. And whenever you will be getting a indeterminate form 0 by 0, that is L Hospital scientist, he explained the procedure for evaluating that limits. Okay, later I will discuss that one. Some standard limits. These are useful for formula based as well as problems purpose also. 1 mark questions, direct formulas, or 2 marks problems or 1 mark problems, that is evaluation of the limits using formulas. Limit x tends to a x power n minus a power n by x minus a is equal to n into a power n minus 1. Limit x tends to 0 sin ax by x. This is nothing but limit x tends to 0 tan ax by x. All are equal to, or instead of is equal to, just put r. Or limit x tends to 0 sin inverse ax by x, or limit x tends to 0 tan inverse ax by x. All are equal to a. Limit x tends to 0 exponential x minus 1 by x is equal to 1, and limit x tends to 0 a raised to x, a power x minus 1 by x is equal to log a to the base e. 4. Limit x tends to infinity sin ax by x, or limit x tends to infinity cos ax by x, a is any number, is equal to 0. 5th one. Limit x tends to 0 1 plus k into x whole to the power L by x, or limit x tends to infinity 1 plus k by x whole to the power L into x is equal to e power kl. But in your lower standards, it is given 1 plus x 1 raised to 1 upon x, 1 by x, like that. But I have given standard generalization where k comma L are constants. So these are the standard limits generally. So while doing problems, if any problem, if any formula if any formula is there, then again you write that formula here in the first page, standard formulas. That means other than these formulas, if any formula comes while doing the problems, again write that formula here. Please by heart these formulas, all of you. and write one more formula. Limit x tends to infinity, x raised to 1 upon x is equal to 1. Limit x tends to infinity, log x by x is equal to 0. Next, while finding limits, you may get indeterminate form, some of the indeterminate forms. 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 power 0, 1 power infinity, infinity power 0, or sum of indeterminate forms. We cannot determine the answer directly. There is a procedure. For this, the scientist L'Hospital rule invented the procedure. While evaluating a problem, if you get like this, these three, there is a procedure for finding that limit. Okay, that is called L'Hospital's rule. L'Hospital's rule. If limit x tends to a, fx by gx is equal to is 0 by 0 or infinity by infinity, comma, then the procedure is limit x tends to a, fx by gx is equal to limit x tends to a, f dash x divided by g dash x, provided the latter limit exists, that is finite or infinite, exist, comma, finite or infinite, that is differentiate NR numerator and DR denominator separately with respect to x. Full stop. Repeat the above process until the indeterminate form is removed. So these are some of the standard examples of indeterminate forms. While finding limits or any mathematical calculations, if you get like this, then the first three terms, 0 into infinity is nothing but bringing into either infinity by infinity or 0 by 0. Okay, if that is numerator is some x terms, denominator some x terms denoted by fx and gx separately, x tends to a. While finding this limit, if you get 0 by 0 directly infinity by infinity, then what is the procedure adopted? Separately differentiate numerator as well as denominator with respect to x. Don't apply u by v like that, quotient rule like that. Okay, provided this limit exists. Suppose if this, in this case also, if you get 0 by 0 infinity by infinity, then repeat the above process until this form, that is 0 by 0 infinity by infinity indeterminate form has to be removed, is removed. Okay, so don't worry, I will show you one of the examples. Okay, one or two examples on these models using standard limits problems and using L'Hospital rule. Please by heart these standard limits formulas and some of the standard indeterminate forms. Now first I am going to start the problems using standard limits. Evaluate the following. 1. This is given 2 marks, 2004. Limit x tends to 9, square root x minus 3 divided by x square minus 81. 2. 2013. Limit x tends to infinity, x tan 1 by x. 3. Limit x tends to infinity, x minus sin x by x plus cos x. This is 2008. 4. 1999. Limit n tends to infinity, n by square root of n square plus n. Limit x tends to 0, square root of 1 plus x minus 1 by x. Now, solution. Write the questions first of all. Now, if you put 9 here, root 9, 3 minus 3, 0, 9 square, 81 minus 81, 0, which is giving 0 by 0. If you remember the differentiation of standard functions, the basic 10 to 20 formulas are there, which are available in the first page of differential calculus. Okay. Similarly, integration formulas, so trigonometry formulas, you have to remember the first 2 pages. Okay, while doing these problems. Okay, not these problems, mathematical problems. Okay. Now, so if you remember the derivatives, you can apply the differentiation separately, numerator and denominator, that is using L'Hospital rule. Okay, but I am doing in an alternative way, in another way. I want to divide first of all numerator and denominator divide numerator and denominator by x minus 9. And I want to express this, root x is x power half, 3 can be written as 9 power half, dividing with x minus 9, divided by x square, 81 can be written as 9 square divided by x minus 9. Observe, anyhow the denominator for this x minus 9, both are cancelled, finally it becomes this only. For this we are going to find x tends to 9. So limit of quotient, difference, addition, sum, product of two functions is nothing but product, quotient, sum or difference of their limits. Okay. So this is in the form of first standard limit formula. N is equal to half, n is equal to 2, a is equal to 9. Okay. So half into 9 power half minus 1 divided by 2 into 9 power 2 minus 1, n into a power n minus 1. Okay. So this simplifies to first of all 1 by 4, 9 power minus of, okay, that is comes down, it becomes 1 by 3, and this is 3 into 9, 1 by 27, that is 1 by 108. Since limit x tends to a, f plus or minus g, okay, or f into g, okay, or f by g, in all these is equal to limit x tends to a, fx plus or minus limit x tends to a, gx, okay, or limit x tends to a, fx into limit x tends to a, gx, or limit x tends to a, fx divided by limit x tends to a, gx. So in the last case, gx denominator not equal to 0, while in the quotient, that is in this case. Okay, this is the formula I used. Now come to this problem. In sometimes whenever x tends to infinity, that is not sometimes, whenever x going to infinity, 1 by x reciprocal both going to 0. So in some problems, depending on the situation of the terms, we convert into reciprocal. What is the meaning of reciprocal? Take out the highest x terms in numerator and denominator if possible, or convert every x term into reciprocal 1 by x. If it is x square, 1 by x square. If it is square root x, 1 by root x. Because x going to infinity, then 1 by x going to 0. Okay, so this is a formula looking like that directly. X going to infinity means 1 by x going to 0. I convert it into tending to 0. This is tan 1 by x. I cannot convert 1 by x inside the angle into any form, but this into x I can write after getting into the denominator, after going into the denominator. That means it becomes reciprocal 1 by x. Now see, just said 1 by x as theta, tan theta by theta, theta tends to 0. So this is equal to 1. Since limit theta tends to 0, tan theta by theta is equal to 1. Here which formula applied? In the first problem, limit x tends to a, x power n minus a power n by x minus a is equal to n into a power n minus 1. Now come to third problem. So just now I told you, in sometimes convert into reciprocal terms. That means bringing into denominator the pre-multiplication terms, which becomes reciprocal. Okay. And in some problems, take out the highest x terms. Here sin x and x. Okay. The polynomial term is x only. Okay. So take the common, take outside. So x into 1 minus. So why we are doing? Because we are comparing just the problems with standard limits. I gave sin x by x, x tends to infinity. So here also, after taking out x, 1 plus cos x by x, limit x tends to infinity. So x cancel. Then compare this formula fx by gx. Okay. So this constant limit is itself 0, 1 plus 0 is equal to 1. So limit of quotient of two functions is quotient of their functions provided denominator not equal to 0. Quotient means fx divided by gx, like that. Now instead of x, this is n given. I told you, take out the highest n terms. N is numerator, single term, we cannot take outside because no use. Okay. In this n square and n square is highest. After taking out, that means from root n square becomes n. So n times square root of 1 plus 1 by n, because n square is not here. Limit n tends to infinity. So n cancel. This becomes limit n tends to infinity, 1 divided by 1 plus 1 by n. So limit of a constant is itself, square root of 1 is itself, 1 by infinity, this going to 0 is equal to 1. Now coming to this problem, 1 plus 0, root 1 1, 1 minus 1 0, 0, 0 by 0, you can apply L'Hospital rule, or this problem I am going to do by without L'Hospital rule, some problems only. Okay, that is rationalizing factor example. What is the meaning of rationalizing factor? So whenever either numerator or denominator a plus b or a minus b, and if you get 0 by 0, then you multiply numerator and denominator with opposite nature. That is a plus b factor is a minus b rationalizing factor is a plus b. So that it is giving a square minus b square in one side, and then square roots are eliminated. After some simplifications, it is removed. 0 by 0 is removed. Let us see. So this is, I am multiplying by, because one more problem is there. I am going to do by 0 form, L'Hospital rule, but this problem I am going to do the basic method. Okay, whichever you feel better, then apply that method. Okay, because they want the answer only finally. So what is the rational factor here? Root 1 plus x minus 1 root over 1 plus x plus 1 divided by x times root over 1 plus x plus 1. Numerator a plus b into a minus b is a square minus b square. After that, roots are cancelled. So 1 plus x minus 1 divided by x times root over 1 plus x plus 1, limit x tends to 0. Here x cancelled, after 1 minus 1 cancelled. So this is going to become limit x tends to 0. Numerator after simplification 1, denominator after simplification root over 1 plus x. So this is going to becomes 1 by 2. Root 1 plus 0, 1, and then there is already 1 in the denominator, 1 plus 1 gives to 2. Numerator is 1 itself. The second method also I am going to do the fifth problem. Or second method, limit x tends to 0 root over 1 plus x minus 1 by x. This is already I told you 0 by 0 form using L'Hospital rule. Okay, root over x derivative 1 by 2 root 1 plus x multiplied by 1 plus x derivative is 1 minus constant derivative alone 0, x derivative with respect to x is 1, and then limit x tends to 0. That means here just put is equal to. Okay, since 0 by 0 form and L'Hospital's rule and derivative with respect to x, that is d by dx of square root x is 1 by 2 root x. Now in the latter limit, if you put x 0, then it gives 1 by 2, just which we already proved in the previous method. The next one is evaluate following. 1. Limit x tends to 0 exponential x minus of 1 plus x square by 2 divided by x cube. This is given 2007, 2 marks. 2. Limit x tends to a x minus a raised to x minus a, 1999. 3. Limit x tends to 0 1 by x minus 1 by sin x. See, if you put 0 e power 0 1 and this becomes 1 and this becomes 0, 1 minus 1 by, that is 0 by 0, you can apply L'Hospital rule, which I have done in the second method of the last problem. Now these expansions you have to remember, that will give in again Taylor series, that is mean value theorem chapter. Anyhow, you remember I am giving the formula e power x is equal to 1 plus, somewhere you write x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, whatever the power, the denominator is same factorial, that number factorial, etc. So using this, this becomes limit x tends to 0 1 plus x square, 2 can be written as 2 factorial. So the first 3 terms cancel and the remaining is x cube by 3 factorial, x power 4 by 4 factorial plus etc. and then divided by x cube. Just substitute this expansion here. The first 3 terms are cancelled, the bracket terms. Now in all the remaining numerator, that is in all the numerator terms, x cube is common. And then after taking common, which is cancelled with the denominator x cube. So we can be written as 1 by 3 factorial x by 4 factorial plus so on. Now limit of a constant is itself 1 by 3 factorial. Remaining are all containing x with numerator becomes 0. 0 by non-zero number is 0. So this becomes 1 by 6. Or you can apply the L-Hospital rule, which I already given in the second method of last problem. You will get again 1 by 6. Now let me do third problem, then I will come back to second problem. So what exactly this gives? If you put directly 0, 1 by 0 infinity, sine 0, 0, this becomes 1 by 0 infinity. So this is an example of infinity minus infinity form. So there is no procedure directly given in L-Hospital rule, but try other indeterminate forms if possible into the first basic form 0 by 0, infinity by infinity. I will show you. So to get such forms 0 by 0, infinity by infinity, you do some simplification, sometimes LCM and some other procedures like that. If you take LCM here, sin x sorry, divide by x sin x, limit x tends to 0. Now if you put x tends to 0, this 0, 0. So this is going to become 0 by 0 form. Finally, whenever you get 0 by 0 form, you know the procedure. Separately, numerator, denominator, differentiate. Sin x derivative, cos x. X derivative with respect to x, 1. This is product rule in differentiation. That is u into v. U into v dash plus v into u dash. That means x into sin x derivative cos x plus sin x into x derivative with respect to x, 1. Limit x tends to 0. Okay? Since by L-Hospital's rule. Now once again see, cos 0, 1, 1 minus 1, 0. Here 0, sin 0, 0. Again second time 0 by 0. Repeat the above process until this form is removed. So cos x derivative minus sin x. Minus 1 constant derivative 0. Here again UV rule. X into cos x derivative minus sin x plus cos x into x derivative with respect to x, 1 plus sin x derivative cos x. Limit x tends to 0. So again why I have done second time also giving 0 by 0 form. Now see third time sin 0, 0. 0 into number 0. Cos 0, 1. Cos 0, 1. So denominator is non-zero. Then you put minus 0, 0, cos 0, 1 plus 1. 0 by any non-zero number is 0. Now second one, so it is going to give this expression going to give 0 power 0 form. So in all other cases, okay, whenever the exponent, the power position is a variable, okay, then maximum type of problems taking first of all logarithms, okay, like that. So let, first of all I am taking this a value y. I don't know that answer y, I mean y value, but some answer I am denoted by y, x minus a, okay. So implies logarithms, taking logarithms to the base c, natural logarithms. So this becomes limit x tends to a, x minus a into logarithm of x minus a. Because properties of logarithm, since logarithm of m to the power n is equal to n times into log m. That means here I have taken logarithms on both sides. Now what exactly this gives? if you put directly a 0, log 0 minus infinity, so 0 into infinity form. Okay, since log 0 value minus infinity. Okay, and logarithm 1 to the base any number except 1, this is 0. Logarithm to the base e to the logarithm e to the base e 1. Here LOG stands for, that means I do not give that base, that means you understood that is natural logarithm only, base e logarithm to the e, or you can write to the base e. Okay, so now try to bring into 0 by 0 form. So here not required to take LCM as in the previous problem. I want to bring the pre-multiplication x minus a into the denominator, which becomes reciprocal. That means this type of case I have done already previously. Okay, now what exactly this gives? Log 0 infinity, and this is 1 by 0 infinity, infinity by infinity. I am not writing negative symbols, ignore the symbols, infinity by infinity. Whenever you get 0 by 0, infinity by infinity, apply L'Hospital's rule. So this is limit x tends to a. What is L'Hospital's rule? Find differentiate numerator denominator separately. Log derivative 1 by x, log x derivative, and 1 by x, that is depending on x power n comparison, which gives minus 1 by x minus a. I told you already, you remember the basic formulas, differentiation, all these things. Okay, since by L'Hospital's rule, comma, I am writing even though the formulas d by dx of log x is equal to 1 by x. Okay, copy down. And d by dx of x power n is equal to n times x power n minus 1. After writing this 1 by x minus a as x minus a raised to minus 1, x minus a whole power minus 1. Now what happens? This simplifies to limit x tends to a minus of x minus a. If you put this big, if you put that is x tends to a, this term going to tending to 0. So therefore finally we got logarithm of a quantity 0 means what is that quantity is equal to 1. So what is this y? We already taken limit x tends to a x minus a raised to x minus a. So therefore limit x tends to x minus a raised to x minus a is equal to 1.